Hello everyone. Well, today I will be having a new topic to discuss, the modulo operations. But before that, let me introduce myself first. I am Jeah Mae Talaub, B Stat 1A in Cebu Technological University main campus. And now, I am formally start with my discussions. Addition, subtraction, multiplication, and division are the most common arithmetic operations that I've ever been encountered. A slightly lesser known, though still very important operator is modulo. In this lecture, we'll focus on the modulo operations. Modulo is a math operation that finds the remainder when one integer is divided by another. In writing, it is frequently abbreviated as mod, or it is indicated with a percent sign. For two integers a and b, when we divide two positive numbers, the equation will look like this. A is the dividend, b is the divisor, x is the quotient, and y is the remainder. Or it could be like this in a short one. Instead of returning the result of the division, the modulo operation returns the whole number remainder. I have here the possibility of return values when a gets divided by b. If a gets completely divided by b, then the result obtained out of the expression turns out to be 0. If b is not able to completely divide a, then the result obtained will be some integer value that is non-zero. In other words, the remainder will be in range of 1 or x minus 1. If a is 0, then division by 0 generates a compile time error. If a is some number or integer and b is 0, then also we get a compile time error. The working of this kind of operator happens on the basis of the value that the end user receives, since it always finds a remainder of the two available numbers or integers with respect to the numerator and denominator. In this lecture, we have to remember that we are talking about remainder and not a quotient of the numerator or denominator. So, let's take an example for this one. 9 mod 2 equals 1. In this example, it is definitely give us 1 as a remainder because when we divide 9 by 2, we get 4 as a quotient, but there remains a remainder of 1. In a similar manner, 8 mod 5 equals 3. In this example, it is definitely give us 3 as a remainder because when we divide 8 by 5, we get 1 as a quotient, but there remains a remainder of 3. Also, 25 mod 5 equals 0. In this example, it is definitely give us 0 as a remainder because when we divide 25 by 5, we get 5 as a quotient, but there remains a remainder of 0. I know all of you confused and eager to learn what happens if the dividend or the divisor is signed and holds a negative value. So, let's recall that the modulo operator a mod b returns the remainder r of the division of a by b. If both dividend a and divisor are negative, then both truncated division and floored division return the negative remainder. So, let's take an example to make it all clear. Negative 9 mod negative 4. We have floor negative 9 divided by 4 is equal to floor positive 9 divided by positive 4 equals 2. And truncate negative 9 divided by negative 4 is equal to truncate positive 9 divided by positive 4 is equal to. Hence, the equality of negative 9 equals negative 4 times 2 minus 1 corresponds to both truncated and floor division, and implies that in both cases we have negative 9 mod negative 4 equals negative 9 minus negative 4 times 2 equals negative 9 plus 8 equals negative 1. So, the dividend, the divisors, and the remainder are all negative. There are another cases. Why would the modulus operation help us when we need to determine if a number is even or odd? So, it is simple. If a number is evenly divisible by 2 with no remainder, then it is even. If a number divided by 2 leaves a remainder of 1, then the number is odd. Mathematics with whole numbers behaves differently when dividing numbers that aren't even multiples. There's always some amount left over. That remainder is what the modulo operation returns. As a matter of fact, these modulo operations contains learning or moral lessons that we can use in life. It just not provide us knowledge and understanding itself, it will also make us learn something from it.